I will be explaining my Java II Midterm project in which I created 3 different programs. And in these programs, I tried to use a modular approach in keeping the code organized. I did so by separating the major tasks into methods. So I guess without further ado, here's our first program, which is called lottery statistics. The goal is to read from a file called pbnumbers.txt, and this contains historical Powerball drawings. So each drawing has 6 numbers, and the first 5 numbers are regular lottery numbers, and the last is the Powerball number. So the first important choice is that I used arrays to store the frequency counts. There we go. So regular numbers range from 1 to 69. So I created an integer array with 70 spaces. Powerball ranges from 1 to 35, 1 to 35. So I created a second integer array with 36 spaces, and so index 0 is not used. This lets the lottery number itself be used directly as an array index, which makes the logic a little easier to understand. So I also used the last seen index array, and this one stores the most recent drawing where each regular number appeared. So that's essentially how the program calculates which numbers are most overdue. So the read lottery file method opens the file using a scanner, and since the file is just integers separated by spaces, which I can show you here. Oh, it's right here. So yes, it's just integers separated by spaces and line breaks. Scanner would be a good fit. So inside the loop here, the program reads 5 regular numbers, and then 1 Powerball number. And the regular numbers update the regular frequency array and the last seen array. And the Powerball number updates a separate Powerball frequency array. So after the file is processed, the number creates a list of regular numbers from 1 to 69. And I'm using integer here, instead of int array because Java can sort integer objects with a custom comparator. Let's see, for the most date regular. Okay, so for the most common and least common reports, the program sorts the numbers by their frequency values. So if two numbers have the same frequency, the lower number appears first, so the output is consistent. And for the overdue report method, the program compares how many drawings have passed since each number last appeared in the drawing. So if a number was never found, it's treated as an overdue for the entire drawing set. And at the end of the program here, we have the display top 10 method, and this displays the 10 most common regular numbers, the 10 least common regular numbers, the 10 most overdue regular numbers, and the full frequency tables for regular numbers and Powerball numbers. So let's give it a quick run and see what that looks like. So this goes from the most frequently used number to the least. So 12 would be the most, and 28 would be the least. And those are the Powerball. The most used regular number is 44, 47 being the least. 23 is overdue. It hasn't been drawn in 91 drawings. And there we go. Let's take a quick grab of that. All right, so now we go on to the second program, which is bank accounts. And this program shows inheritance and method overriding. So I created an abstract class called bank account. So you can see here. And this stores the shared information for a bank account. So it has the balance, number of deposit, number of withdrawals, so on and so forth, as you can see here. The bank account class has methods for deposit, withdrawal, calculating interest, monthly process. So the deposit method adds money to the balance and increases the deposit count. The withdrawal method subtracts money and increases the withdrawal count. The interest calculation calculates monthly interest by dividing the annual interest rate by 12 and multiplying the balance by that monthly rate and adding the result to the balance. The monthly process method follows the order that was required in the assignment breakdown. So it subtracts the service charge first, then it adds the interest and resets the monthly deposits and withdrawals and the service charge back to zero. Then our savings account class extends bank account, so it inherits the general behavior of this class, but adds its own rules that solely applies to itself. So the most important of that being the active status. So you can see here, if the balance is below $25, and the account becomes inactive. So what that one does, and I overrode the withdraw method because it shouldn't be allowed for or while the account is inactive. So if the account is inactive, the method prints a message and doesn't call the superclass withdrawal. If it is active, then it calls the method to reuse the original withdrawal logic. I also overrode deposit. So a deposit is always allowed here because an inactive account needs deposits to become active again. So after the deposit, the program updates the account status. With monthly process method, it's overridden as well. Before calling the superclass version, the savings account checks whether there were more than 4 withdrawals. If there were, it adds $1 in service charges for each withdrawal over 4, then calls the superclass monthly process. So let's give this one a run. Oh. Alright, let's start with $100. Low interest rate there. And let's just do one deposit. I'll deposit $50. And let's do Alright, so as you can see, we started with 10. We only made one deposit and we withdrew 6 times. For processing, we got $90. And then we got a charge on that 5th withdrawal. And it calculated our interest. So we have $88.44 at the end. Alright. Let's get into the third one, and this one is the employee payroll. So I started by our main method starts here, but I created a payroll class that stores the employee name, ID number, hourly rate, hours worked. And it calculates the gross pay by multiplying hours worked by hourly rate. So the fields in payroll are private, so they can't be changed from outside the class. So instead, we use an accessor and mutator method. So the constructor accepts the employee name and ID number, and it calls the setter methods within it instead of assigning the fields directly. And this avoids duplicate validation logic and keeps the rules in one place. And I also added 4 different exception classes. So we have invalid name exception, which is thrown when the ID number is 0 or negative. We have invalid hours exception. This is thrown when hours are worked less than 0 or greater than 84. Invalid pay rate is when the hourly pay is less than 0 or greater than 25. So in the main program here, I use a try block around the input and object creation. So if the user enters valid information, the program displays the employee name, ID, hours worked, hourly pay rate, and gross pay. If invalid information is entered, one of the custom exceptions is thrown, and the catch displays a clear error message of what the issue is. And this just makes the program more reliable. And yeah, so let's run this one. Employee name. There we go. So ID number can't be 0 or negative, as we see there. And there we have it. Thank you so much for watching my presentation. Have a good one.